So today we will be looking at the first biomolecules, which is very common in our daily life. We usually just call it by the name of carbs. So the full name of carbs is really just carbohydrates. Carbohydrates. So carbohydrates, commonly known as carbs, is really a general name for every sugar that we know of. So in other words, we can just look at it as a sugar family. The basic definition of carbohydrates is organic molecules that are made out of sugars. Organic molecules made of sugar. Not just simple sugar, and also their polymer. So if you remember in our last class, polymers are really just a group of covalently bonded monomers. So along the sugar family, we have very small and simple sugar, small sugar molecule. We also have medium-sized polymer, medium polymer. And we also have large, giant carbs polymer, which is made of many polymers, many monomers. The scientific name for carbohydrates is really just saccharides. Saccharides. So the saccharides family is derived from the word of sugar. So think of it as a fancy name for sugar, saccharides. And we know that to make a big biomolecules, you need at least two monomers. So monomers is the building block for polymer. So if you have monomer and monomer bonding together, you're gonna get two monomers binded together. In this situation, we call it a dimer. So dimer is two monomers bonded together, and when you bond two monomers together, you're gonna release a water. This particular process is what we call dehydration synthesis, which is the removal of water to make something, synthesis. So in the case of carbohydrates, we're going to have the monomer for saccharides. So it's called monomer of saccharides. So the name is monosaccharides. If you add another monomer of saccharides, which is monosaccharides, you're gonna get a dimer. So the dimer of a saccharide is what we call a disaccharide. And since this is a dehydration synthesis, you're gonna release one water molecules. So this is how you form a disaccharides. If you wanted to use a model to represent this, if I had drawn this particular polygon to represent a simple sugar, it bonded with another simple sugar. So it's bonded with another simple sugar. Now I have two monomers bonded together. We call this a dimer. If this is a sugar, we'll use this to represent sugar. This is what we call a disaccharide now. If I have more simple sugars coming together, and they're each covalently bonded and remove lots of water, now I have made a long chain of saccharides. So this saccharides is just gonna go on and on and on and on. We call this a polymer of saccharides. So the scientific name of a polymer of a saccharides is what we call a polysaccharides. So now I have made a polysaccharides, and the process of making this is what we call a dehydration synthesis. So if we zoom in to look at each monomer of glucose, of sugar, the scientific name of the monomer of sugar is glucose. There are many different types of simple sugar, but the most common one is glucose. The structural formula for a glucose looks something like this. No worry, you don't have to memorize this in my class, but it's good to recognize the shape of it and how does simple sugar get the iconic hexagonal shape. So now I have finished drawing a simple sugar. This is glucose. So if you count the number of carbon, you'll realize that there are 6 carbon in a glucose. And if you look at the number of hydrogen, you'll realize that there are 12 hydrogens in one glucose. If you look at the number of oxygen, you're going to realize that it will be 6. So to write the chemical formula for a glucose, it will be C6H12O6. This is a very common thing that you're going to see in later parts of biology. This is glucose. And if we focus on the ring shape of this glucose, you'll realize that each carbon is going to have 4 bonds bonded together, bonded around the central carbon. So I'm going to have 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon in this particular ring shape. So what I can do is I can simplify this ring shape into an abbreviated structure. So I'm just gonna link the ring shape, and it's going to create something of like this, with oxygen here. So if I keep filling out the blanks, this will be CH2OH, H, H, OH, OH, H, H, OH, OH, H. Now, this is what we call an abbreviated structure. We simplified the carbon because we know that the central atom in a glucose must be carbon. So this is an abbreviated structure. We just take out the carbon of glucose. So if we further simplify it, we take out every other atoms in there besides the oxygen that connects the ring shape, you're going to get something like this. Oxygen, 1, 2, 3, 4, 6. And there we go. We now have a very simplified shape of a glucose. Simplified shape. By this, I can recognize that there are 6 carbon, 1, 2, 3, 4, 5. And we usually just omit the 6 carbon. We know that there must always be 1 carbon here in the ring-shaped structure. So this will be the 6th carbon. And that's how you get the hexagonal shape for a glucose. And this has 6 carbon in it, so we call this a 6 carbon sugar. We have a scientific name for it. It's called a hexose. Hex represents 6 carbon, 6, and ose just means sugar. So if you see lots of names with ended with OSE, you know that it is a type of carbohydrates. If you go down further, I can draw something like this, O, with a pentagonal shape. If you do calculation, 1, 2, 3, 4, is this a 4 carbon ring? Nope. There is going to be a 5th carbon that we just omit writing. So by looking at a pentagonal shape, I know that this is a 5 carbon sugar. So a 5 carbon sugar, we just call it a pentose. Pent means 5, ose means sugar. So this is a 5 carbon sugar.